700 students now, including the doctoral degree, master, and also bachelor.
So you have a system of the first degree is a bachelor, which is a 3-year course?
Yes.
Not 3 years, I think 4 years.
3.5 years, something like that. And then master degree 2 years.
3 years.
And then PhD
Yes,
is
4 or
3
more.
or 5 years.
Okay. Right. And it says, does the institute have a special focus on drive systems or energy generation or control systems, or is it general?
We have actually telecommunications, computer engineering, electrical power, control theory, and also microelectronics. And then for the control and also power, we are very close. Actually, we won't develop the issue of microgrid system, smart grid, let's say, smart house. Now they are running at I think we have support from Alexander Kaup also, some equipment. And now we are going to this direction, microgrids, smart microgrids, something like that. Online monitoring system.
Okay.
Yeah.
Is there or perhaps I should introduce myself
Yeah.
first. Okay. I head the energy storage group here at the Institute of Electrical Power Engineering. This is the correct term. The Technical University of Clausthal is or one of the smallest universities in Germany. Currently, it's 4,200, I think, students of first years, including PhD students. The focus of the university is on energy and raw materials. This used to be a mining area. In fact, one of the I think the mine worldwide that operated the longest continuously is in Clausthal, Ammersberg. You may have visited it.
Yes.
I think it started in the year 2050, which is nearly 1,000 years ago, and it stopped mining I think 30 years ago. So I think there's no mine worldwide with a longer history of continuous mining. Obviously, the materials were silver-based, so silver zinc lead, and the university here was originally the training center for the engineers and the supervisors for the mines. You may have heard of not you may have, I'm sure you have heard of Gauss, the one with the Gauss curve. He at one time worked here in for the mining area in Clausthal. Nobel, the person who invented dynamite, he invented dynamite here in Clausthal as a safer method of blasting mines. So this is an area with a long mining history, but of course today mining in Germany is not very important anymore, and the faculty of mining is a very, very small one now. The Institute of Electrical Power Engineering, there are two institutes which are involved with electrical engineering. The one is Institute of Electrical Power Engineering, the other is called Institute of Electrical Information Technology. They're the people who do the control systems and measurements technology. Here we have 3 groups. The one is energy storage, this is my group. The other is electricity distribution on the the low and medium voltage level. And in Germany, probably worldwide, there's good knowledge of how the electricity system works on the high and highest voltage level. And lots of, every transformer there is measured and controlled, and data links, and the control center knows exactly what happens at the highest voltage level. At the low voltage level in Germany, well, there's a transformer, and the voltage is the way it is. What is measured is consumption at the point of use at the household, but there's no measurement infrastructure, no knowledge really of the grid at all. And we are here one of very few institutes who look at the low voltage grid. And in fact, actually, if I can immediately enter into a discussion, there's a problem in Germany at the moment. If you have here voltage, and here distance, and here is the transformer, and from here onwards it's 400 volts. Okay? So, and traditionally, the voltage goes something like that. Yeah?
Yeah.
Okay? So you have your low voltage level, and you have a high voltage level. Okay? And you make sure that the transformer here, the voltage here goes up and down as well, is set in such a way that here you're always above the low voltage, and here you're always below the high voltage. I mean, it's the same everywhere. Now that's fine, and along come people like Alexander Karp or myself. I have one of his PV systems, and we are generating electricity. So all of a sudden, there are no longer only consumers here, but also producers, and the voltage doesn't really look like that anymore. In worst case, it looks like that. That's 12 o'clock noon, and like this at 12 o'clock night. Okay? And all of a sudden, the voltage spread that is allowed is no longer valid. So what you do, either the people during the day their equipment gets damaged because the voltage is too low, or at night the equipment is not operational because the voltage is too low. And there are a couple of solutions to that. The one is what is called a controllable low voltage transformer, which it's an electronic control. It's not sort of a mechanical switch going from one to the other, but it constantly controls the voltage to an appropriate level. That is one. The other is that the inverters from SMA provide reactive power to shift the voltage. One solution would be to install batteries here. I have a battery, and I don't feed in as much electricity during night, and I don't use so much electricity at night. So that is the low voltage issue, and it's an expensive issue. E.ON Avacon, which is the local utility here, or local distribution utility, they run the medium voltage level. They say that it will cost them 1 billion euros, 1,000 million euros, if the only solution that they have is dig up the roads and put in thicker cables. So a lot of money that is at stake, and they're investigating all sorts of things, and they believe a cheaper solution will be changing over the transformers. So this is a real issue. Anyway, this is one of the research areas. Also, among in this group, there's always interest in the gas system, in the gas distribution system. gas and electricity are basically two totally different things. But if you look at them from a control point of view, same thing. I won't say there's no difference, but the differences are really limited. In both cases, you have the same problem of not having enough measuring infrastructure, but having to know what happens locally. So, you know, you have to have some advanced control systems, control algorithms which estimate the state of the system in various times and places. And the third group is called mechatronics. They're the people who operate drives and make sure that the drive works in such a way that that nothing breaks. Perhaps at the end of the meeting we can go via our sort of laboratory hall, and we'll be able to see some of the machines. The battery installations is most of it is not here anymore. The distribution system also, there is very little laboratory, and what there is in Clausthal, but the machine people, they have quite a lot of equipment there, and I can tell you some of the research that they do there. So this is the Institute of Electrical Power Engineering. There are about, I think, 15 currently. Yeah, 15 scientific staff.
15.
Who do research projects and of course do assisted teaching. Yesterday there was a big exam, and one of them, in fact 2 of them of the institute today do nothing but correct. 550 students, so you know it's not a fun day for them today. Right. Did I miss anything as far as the university is concerned?
No.
No, I don't think so. Okay, my speciality is batteries. When people talk about batteries, a lot of them now talk about lithium-ion batteries as the which is a very good system, no doubt, but also a fairly expensive system. And put it that way, hardcore battery people like myself, we believe in the lead-acid battery as being a permanent solution. And I think when you talk about batteries and solar systems, I think you should be talking about lead-acid batteries and not about anything else. The cost of a lithium-ion battery system is so much greater. Okay, the efficiency is a little bit better, lifetime possibly a little bit longer, well, possibly quite a bit longer, but not proven yet. You know? I mean, laboratory, yes, long time. It's application. Well, we'll see. So there are lots of possible benefits. Fair enough, but whether they're proven remains to be seen. And from a cost point of view, it's probably cheaper to replace a lead-acid battery every 4, 5, 6 years. Instead of replacing a much more expensive lithium-ion battery, perhaps once every 10 or every 12 years. So lead-acid batteries, I think, is the system that you should be looking at, and certainly is the system that we also do research in. We think that lead-acid battery is a permanent battery. Everybody who does research in batteries doesn't really trust batteries.
You explain what
I've recharged this. I think the battery is still very good actually. It's an old mobile phone. I've recharged this yesterday evening, when I go on a trip, I always have all chargers for all batteries with me. Not like the young generation who say, well, I've charged it up, I go on a 3-week holiday, I don't take the charger with me. Never ever, you know. Having a battery means thinking about replacements and alternatives and chargers. So I'm saying this because I believe that in solar systems, if you have a grid connection, use the grid connection. The grid is the cheapest way to store electricity, if you like. Of course, it depends what your utility charges you for it. If they say thank you for providing me with electricity, and if you want some electricity, they charge you full price. Bad idea. If it's a more reasonable solution, like if you have electricity, I buy it from you at the cost that I would have anyway from the power station, and then probably wherever you are, you know, using the grid to just get rid of excess electricity and using the grid to draw electricity at night is probably the better solution. But it depends on the cost structure. And how expensive is electricity in your country? How much you pay per kilowatt hour?
Very cheap actually.
Subsidy.
Very cheap.
It's subsidized.
Yes.
Okay.
0.1 $0.1
$0.1
for 1 kilo.
What, $0.1?
Yes,
$0.1. That's about
1 kilowatt hour.
8 cent.
Yeah.
Oh.
the cheapest.
And your government has enough money to do that?
Yes.
That's
Oh,
but
I
until when? That's the question.
Actually, that's why every years they are
Increase.
increasing the price of the energy.
Yeah,
Actually,
8%.
And what is your cost structure? In Germany, it's like this. You have a connection fee to the grid, which is about €100, and then it's about 0.25 euro cent per kilowatt hour. So it goes like that. What is your cost structure? Is it zero like that, or is there a connection fee?
Yes, there's connection fee
What?
for the house service or what? How much?
You mean the connection fee from the grid?
From the grid to the house, yeah.
Yeah, just the pleasure of connection. Whether you draw electricity or not.
This is around
Just
around 2 million rupiah.
Yeah.
Yeah.
For installation.
Yeah,
for
installations.
For installation in
Let's
the every
say-
house, yeah.
Okay, so you as a house owner have to pay for
Yeah,
the
for
connection.
first install, yeah.
And after that,
No,
no more.
every month we got meter, we pay
Okay, but once you've paid the 2 million,
for just
Rupees?
install.
you're now connected to the grid,
Yeah.
Right?
and then 1 month you don't use any electricity at all. What do you pay?
We get minimum, what's called that? Yeah, beban,
Yeah.
So-
But
so
very
it's-
low, yeah.
So it's something like that. Something like that. You pay a little bit, and the more you pay, it's like this.
Yeah,
Yeah,
depend on
on
the
the
consumption.
consumption.
Yes.
Yeah.
Yeah. Okay. So yeah, the more you consume, it goes up.
Yeah,
But if you
yeah,
consume zero, you still pay
Just,
a little.
yeah,
Still pay
minimum.
Yeah.
How much is 2 million rupees?
It's around
200.
200
US
200 euro.
No,
dollar.
no.
No, US dollar.
200 euros for the connection. Oh, wow.
That's not bad.
That's
200
Yes.
US dollar.
Yes, around
Yeah. Yeah, okay, around.
okay. Not particularly expensive, I would say. Okay.
and it's also depend on the capacity of this house. For example, in medium for the medium load, it means around 200 watt,
Mm-hmm.
2000 watt,
2000
yeah,
watt.
we have to pay around this, and for the 900 below, maybe more cheaper.
Okay.
Yeah.
So it looks to me as if you have the same problem that we
Yeah.
have, that the electricity price that one pays does not reflect the cost.
Yeah.
So things get very difficult, I think,
Yes.
you know, because you're comparing real cost.
Yeah.
I buy a photovoltaic panel, I buy an inverter, I buy a battery, with a artificial price which will change or not change or whatever. Yeah, difficult.
It's not
Anyway, certainly for Germany, I believe that it's for me to install my own battery in order to save, in order to consume my own electricity, is very expensive. It's a sort of if one believes in personal autonomy, I don't want to have anything to do with the rest of the world, and I'm self-sufficient. Yeah, fine. But if one's quite happy with having a grid, then it's expensive. Of course, in Germany, electricity supply, the quality of the supply is very good. Germans, I think, feel it a violation of their human rights if the power fails,
no blackout.
Yeah, if the lights go out and on again, 1 second, they say, not good enough. And I still remember about 3 or 4 years ago, there was quite a major blackout here. It took about half an hour, 2 hours, something like that. Must have affected you in Schladming as well, because what do you call it, earth-moving machine sort of black out a cable, and that was about 5 years ago, something like that.
Cannot remember.
Maybe around 2005, 2007, I have in Kassel, and then there was a blackout.
It may have been the same thing. It happens so seldom that we remember these things. Now, I know that in India, they say that if you live in an area with high quality power supply, I think you reckon with 1 hour electricity outage per day. Of course, if that is the situation in your country as well, then of course the battery, is a perhaps not a luxury. It's still probably a luxury, but it's a very useful luxury to have. And I don't know what is the quality of supply in Jakarta or in the rest of Indonesia.
Yeah, in Jakarta it's normally quite good, I think. But maybe for the in the remote area, or maybe this is very sometimes
Also
they
in Sumatra,
Sumatra Islands is the
Yeah,
biggest
that's
island.
also.
Also, maybe they have some problem with power quality and also supply. Maybe they can one day the take out maybe 2 times. Yeah.
So on a minute per year basis, what would you be having?
In the island, when they regular.
Do you know the figure for Germany? I think
No idea, I cannot remember also for a blackout or brownout for myself.
I have something like 8 minutes a year
So much.
on average, which consists of 1 second blackout per year, and one
So-
half an hour blackout every 5 years. That's about it.
Right.
So,
As every week or so. Jakarta, Jakarta.
so every few days.
Yeah, and at least 2 weeks.
Yeah,
And of course, then the
Jakarta,
battery
yeah.
is important. Tonight there's the football match between Germany and Holland.
Alright.
So, no.
And so if
Something.
if there's power failure then,
We can't. National issue.
so yeah, if of course, if you have if you think that I want to use electricity when I want to, always, then of course the only thing that you can have is a battery, small UPS system.
Yes, money.
Okay. So basically, I believe that if you have a grid connection, a battery is something for blackouts, for UPS requirements, for luxury, but as far as sort of economic method of producing your own electricity, storing it, and using it later, not really. But of course, in autonomous areas, and I'm sure in Indonesia you have masses of them, you have to have a battery. There's no way around it. Well, no way around it. But I can tell you of a system in the north of Scotland, somewhere near Iceland. This is Britain. Here's Scandinavia. Okay. Here's Germany, and here's Britain. Here's London. Here's Iceland. And there are a couple of islands here. 100, 200, 500 people there. That's it. And plus lots of sheep. And one of these islands has a system which looks like this. They have windmills, which are some sort of AC converter. That's the AC bus bar. And they have diesel generators with probably directly connected like that. Okay. And then they have loads. And they have, I think it's 3 category of loads. Okay. And these switches are frequency controlled. These loads have to be supplied. Lighting, telecommunication, I don't know what else. And these loads are loads that don't have to be available now. Heating and warm water, provided you have a storage tank. Whether you produce your hot water now or in 5 minutes makes really no difference. And these are, the second is things like refrigerators and washing machines. Again, if they run now or in 10 minutes or an hour later, it doesn't matter. And the way the system works is, it works without batteries. The way the system works is that when there's a lot of wind, then the diesel generators are switched off. The frequency here is maintained at 50 Hertz, and any excess electricity is used for these. When there is too little wind or no wind at all, the diesel generators run. Additional wind, again, is used to to feed in the system. Doesn't get thrown away.